Hello everyone. In this video we are going to do column design referring IS Indian Standard Code IS 13920 and Indian Standard Code 456. So we have already analyzed, I have given the link, also the multi-story building. We have calculated the load, then we have analyzed, and from these forces now we are going to design the column DA, which is an exterior column. So this is X and Z direction of elevation of multi-story frame, and this is plan X and Y, and our column is in this position. Okay, so now we have already assumed the size of the column while doing the load calculation as 400 mm cross 500 mm. So if I look at the sizes, this is 500 mm in this direction, and this direction it is 400 mm, the column size. So referring to IS 13920 clause 7.1.1, we are going to check the member sizes. So our width is 400 mm. Now this is greater than minimum width required 300 mm, so this is okay. Next, our width to depth ratio. So 400 by 500 versus 0.8. This is greater than 0.4, so this is also okay. Next, our depth, which we have taken as 500 mm. This should be greater than 20 of diameter of bars used in the column. So let's assume that we are going to use 16 mm dia bar. So 20 into 16, 320 mm. Now this is also greater than 500 is greater than 320 mm. So our size, member size is correct. Okay. Next, we are going to check whether our column is short column or slender column, because as per that our design may change. If it is a slender column, then additional movements will come into picture. So as per IS 456, if you refer annexure AE, your effective length will be 0.65, this factor, because here your boundary condition is fixed at bottom and also fixed at top, the DA column. So I'm going to take 0.65 factor into our length of the column is 3 meter. So into 3000/1950 mm. So the effective length by our minimum dimension of the column 400 mm is 4.875. So this is less than 12. Okay, that's why it is a short column. Okay, so we are going to design this as a short column. Now in IS 456 we have, if you refer clause 26 into 26.5.3.1 of IS 456, our minimum reinforcement should be 0.8%. okay, so 0.8% of the dimensions. So our minimum steel should be 1600 mm square, and maximum steel we have to provide, so we can only provide 4% into 400 into 500, which is 8000 mm square. Okay, so this is as per the clauses. Next, what are the forces? So if you refer to the video which I've given the link, we have analyzed the structure. So as per the analysis, we have got that for vertical load, dead load plus live load, our force in DA column, so this is for exterior DA column. Okay, the forces were, so the axial force was 82.64. Then in MY direction we had having 10.93 kilonewton meter. Okay, so then we have earthquake in x direction we have analyzed. So it was 44.922, and we didn't have in x direction moment. This was 46.275. Okay, so let me show you. So this was the column in elevation I'm showing. So we have analyzed in earthquake in x direction, right? So there was a shear force that we have calculated into, if you do this length by 2, you will get the moment, right? So this is our moment my, which we have got 46.275, right? Now there was also a beam, right, in this direction, for which the shear force was there. So shear force into this perpendicular distance will come in this way, the moment. So this is also same direction. So I'm going to, so if you see, so this direction shear force, if I take, this will come in this direction. Okay, so we have my in both direction. Okay, due to beam and due to this column. Now if I look at the plan of the multi-storied frame, our column is here. So we have analyzed for this frame, right? So for this frame, for the earthquake load, okay, it will always take in the one direction only this columns will participate when it is this earthquake direction. But coming to dead load and live load, we will also have forces in this beam. So from this beam also the moment will come. So this will come same 10.93, because our spans are different. So if you are analyzing this direction, if you are analyzing this direction, so you will also get force in mx. Okay, so that's why I'm putting 10.93 in mx. So drawing this column, we have x-axis axis. So this we have taken this DA column. I'm going to draw. This is 500 and this is 400, right? So our mx is moment about x, moment about x-axis. So if you refer some books, you may find like moment along x-axis and about x-axis. That means if I write it is x-axis mx, it is about x-axis, or I can also tell along y-axis. Okay, so this is our y-axis. Okay, this is our y-axis. So now the moments that we have calculated, my is this and mx is this. Okay, so let's calculate it for the load combination, because there are many load combination. I'm going to design for one dead load plus live load. So it will be plus or minus earthquake in x direction. So I'm going to add it. So this plus this into 1.2, 153.07 kilonewton. So this into 1.2, 13.12. So this I'm going to take the maximum plus or minus. So I'll be designing this for this plus this into 1.2, 68.64. Okay. So now you see we have P, Mx and My. So this column will be designed for biaxial bending. If we have only one moment, then it will be designed for uniaxial bending. So if it is a uniaxial, it will be more easy, because directly you will be referring the chart where you can directly find the steel from P by FCK BD value and mu by FCK BD square. For biaxial bending, you have to first assume a steel reinforcement. So let me assume the minimum steel 0.8%. So P by FCK is 0.8 by 25, which is 0.032. Next, you have to find PU by FCK BD, which is 153.07 into 10 to the power 3 by 25 B into T. Okay, so 0.03. Now D dash by D. So D dash I am taking if it is 40 mm clear cover plus your ties or links 8 mm and 16 dia bar. If I am using longitudinal reinforcement, this by 400 I am taking 0.1 approximately. So this is if I am going to now calculate uniaxial moment capacity. Okay. So this in XX direction axis and we will calculate in YY axis. Okay. So now this 400 is for XX axis. Similarly D dash by D in YI axis same, above 40 plus 8 plus 16 by 2 is 56 by 500. Because when you are taking X axis, your width will be 500 and depth will be 400, whereas in Y axis it will be just opposite. So this also approximately 0.1. So here if you refer FCK BD square is equal to, so if you are referring this to, you will chart from SP16. You will get this value. So if you refer the chart, the moment capacity, you will get the value. So refer chart number 44 for this value. So mu FCK BD square, this value will come 0.06. So here mu in x axis, the uniaxial capacity will be 0.06 into FCK B will be 500, D is 400 square, FCK BD square. So this by 10 to the 6 to calculate in kilonewton meter. So you are going to get 120 kilonewton meter in x axis. Similarly for y axis, mu by FCK BD square, same 0.06, referring the same chart, because here D dash by D is same and your PV FCK BD is same, so value will be same. But if you calculate the in y axis, your B and D will be changing. So 0.06 into 25 into 400 into 500 square, so by 10 to the 6, this is coming 150 kilonewton meter. So both capacity you have calculated, both direction. Now you have to check whether the assumption is correct or not, right? So for that we need to first calculate, referring clause 39.6 of IS 456, PZ you have to calculate using this formula. So this is 0.75 FYASC. So 0.45 FCK is 25. Area of concrete is 400 into 500, the dimension of the column. But you have to here deduct the steel area. So 0.8% I'm going to reduce the steel area. So this plus 0.75 FY is 415 and steel reinforcement is 0.8% of 400 into 500. So this comes 2730 kilonewton. Okay. So now calculating PU by PZ value. So your value 153.0 is 1 is the axial force. Now your capacity is 2730. So which is coming 0.056. So this is less than 0.2. This implies the one factor is alpha n is 1. This we have to use to check this equation, which is mx by mux, the capacity, by alpha n, plus my by muy alpha n. So this is what the moment coming on the column is 13.12 in x direction for this load combination, by capacity is 120 to the power 1. So this you can refer in the clause, same clause 39.6, this value is given. Okay, if it is less than 0.2, you have to take alpha n as this 1. So plus in y direction 68.64 by 150 to the power 1. So your value is 0.57, and this value 0.57, and this value is less than 1. So your assumed reinforcement P percentage, which is 0.8%, is correct, is okay. Okay, so you don't have to do redesign. So 0.8% means 1600 mm square you have to provide steel, which is equal to 1600 by, so we have assumed 16 dia bar, so 8 numbers of bar we are going to provide. Okay, 8 numbers, 16 dia bar. So if now this is your column, this is 500, this is 400. So you are going to provide 8 means, let me provide 3 here, 3 at bottom, 6, so 7 and 8. Okay, so 8 numbers of 16 dia bar I am providing, and we have to provide also the ties. So in the next video I will be designing as per IS 390 what is the shear requirement. In this video we'll just end it calculating as per IS 456 what is the minimum pitch. So the spacing should be less than equal to 300 mm, or the minimum lateral dimension, which is 400 mm, or 16 into dia bar, 1660 256 mm. And the this tie bar dia should be greater than 16, which is the dia of the bar, longitudinal bar, 16 dia by 4 mm, and it should be minimum greater than 6 mm. So we have to use, so it is two-legged because we are having two-legged. So using two-legged, this is the minimum 6 mm dia bar at the rate of, this is 256, so I am going to provide 250 mm center to center. So this is the minimum, but in the next video I will be which I have given the link, I have analyzed the shear requirement and what is the exact shear or what is the exact transverse reinforcement we need for this column. Okay, otherwise as per this analysis we have provided 3 longitudinal bar, so this will be going inside the foundation. Okay, and the tie, which is 16 dia bar, and this ties of 6 mm dia at the rate of 250 mm center to center. Hope this video is useful to you. Thank you for watching and subscribing.